Okay, today we're going to look at friction. So friction is a force that opposes movement. So whenever something's trying to move, friction is something that would try to stop it. Friction occurs in many situations that we're simply not aware of. There are different types of friction which are shown here. So first we have static friction. This occurs with objects that are at rest. Next we have, on the list, we have sliding. This is when something is trying to move without some type of wheel or sphere. And rolling involves wheels of some type, and then there's fluid, which has to do with a liquid or a gas of some type. Now these types are in order from greatest to weakest. So static friction is the strongest type. If you look on the bottom of a laptop, sometimes there are these, I'm not sure if you can see them, but like little rubber pads. And the reason that those are there is if you put it on a table and something happens and you hit the side of the computer, it won't slide off the table. But if it started to slide, then it would have sliding friction. If you look at this bottle, if you were going to tilt it on its side so the fluid would come out, then you would have fluid friction as it moved across. Sometimes you can find rocks that are very smooth near a lake or a river, and that's because the water over many years has kind of flowed over it, and that continuous friction wears them down. So again, this is most powerful to least powerful, static, sliding, rolling, and then fluid is the weakest of all. So looking at this in context, if you were to summarize this, let's say that you have a box on the floor and you're pushing. Well, here's the idea. The friction that is applied is in the opposite direction. Remember, the Newton's third law states that forces always occur in pairs. So as soon as you push this, you're going to have some friction that is going to be trying to resist that movement, and that direction of that force is going to be in the opposite direction. However, notice that the magnitude of the pushing force is greater than the magnitude of the friction force. Therefore, you're going to have an unbalanced force, and you're going to have overall movement to the right. So let's look at this question. You pull a wagon with 8 newtons of force. The rolling friction is 3 newtons. What is the acceleration of the wagon if its mass is 50 kilograms? Take a moment, try to solve that, and then I'll talk to you about the solution. Okay, so you can surmise that if you are given a number for force and you're given a mass, then you're probably going to be using the F equals ma formula. And that is accurate, you are. So F equals ma. The problem is you don't really know what the F is. So if you look at the wagon, and let's say you're pulling that wagon with, it doesn't really say which direction, so let's just assume it's going to the right. So you have 8 newtons of force to the right. However, you also have 3 newtons of force, and remember that friction is always in the opposite direction. So here if we have 3 newtons that is subtracted from that, we have an overall resultant force of 5 newtons. Now, over here, I have 50 kilograms, all right? So 50 times something equals 5. To find what the answer would be, you have to divide both sides by 50. So you're going to have 5 over 50, and that's going to be 1/10. So your acceleration is going to be 0.1 meters per second squared. Okay? So go ahead and complete your fever form, and we'll talk about it tomorrow.